is talking about end behavior. As something is approaching something else. There's two graphs up there, yes? When you talk about end behavior, you're talking about something that's happening at the end of the graph. So if I am looking at this first graph, this is how you would say this. And unfortunately, we don't do as much of this in this class as I would like to, but we're just going to do a crash course. What you would say is, you would say, as x approaches negative infinity. This is talking about end behavior. This is going to lead into limits. So if we're approaching negative infinity on my x-axis, which direction are we going? You're going left, right? So as I'm going this way, what's happening with my graph? So as I'm going this way, my graph is doing what? It's going up towards what? Infinity. Positive infinity. So you would say as x approaches negative infinity, f of x approaches positive infinity. Have I done my entire end behavior? I've only done one half, right? So I've done as x approaches negative. So then I'm going to say as x approaches positive infinity, what's happening to my graph or my f of x? It's going down. It's going to negative infinity. Okay? I would like you to try the same thing for graph number 2. As x approaches negative infinity, what does f of x do? And as x approaches positive infinity, what does f of x do? So as x approaches negative infinity, what's happening with my graph? This one's negative infinity. Now, is it going like this?
Oh, it's going to
zero. No. Where is it going? What does it look like is right there if I were to draw that? Yeah. What? What looks like there's something in the graph right there, right? Kind of causes a pause, right? So everybody see how it's like squirming right up against it but not quite hitting it? This is important. There's also one here, correct? You see where something's shooting straight up? What is that called if it's approaching but not hitting it? It's called an asymptote, right? We have 3 types of asymptotes, We have horizontal, we have vertical, and we have slant. There's actually a slant asymptote in here as well, but we don't really deal with those with limits. But vertical and horizontal definitely happen. So if I were to kind of draw that right there, does that kind of look like a horizontal asymptote? Do each of those endpoints kind of skirt along that but not hit it? So we would say as x approaches negative infinity, f of x approaches 1. Okay? And then as x approaches positive infinity, f of x approaches 1 as well. Okay? As they approach. Now, the concept of a function approaching something else is coming to its limit. That is called your limit. This is officially the first day that you are doing big kid calculus. We're not doing baby calculus in here. We're doing big kid calculus. Pre-calculus. So I took the pre off and we're fine. Pre was first semester. All right. The notation is really important when we talk about limits. And I will be picky about how you say it. I'll be picky about how you write it. Okay? Here is how you write such notation. You will write the limit, LIM, completely fine. Your limit will always be x approaches some value. It'll never be y. It will be y when you get into Calc 3, but most of you aren't going to go that far, and that's fine. The limit is x approaches c of f of x, of whatever my function is. Sometimes it'll be a function. Sometimes it'll be a number. Sometimes it'll be an equation. My limit as x approaches c of f of x equals a capital L. Your limits will be labeled as a capital L. Okay? All right. So the first thing we want to do here is we want to write end behavior as a limit. So here's what we will start by doing. Let's talk about end behavior first. What's happening here is x approaches negative infinity. What's f of x doing? It's going to negative infinity, but we're going to write it in terms of a limit. So we're going to say my limit as x approaches negative infinity of f of x equals. What is my limit as x approaches negative infinity? What is my function doing? It's going down, right? It's going towards what? Negative infinity. Oh, thank you. Okay, is that my only limit? Macy, I'll give it to you in just a second, okay? All right. My other one is going to be my limit as x approaches positive infinity of f of x equals what? Negative infinity. Okay? I would like you guys to try the following ones. I would like you to try bottom middle, top right, bottom right. Write your limits as you're approaching. Write your end behavior as a limit, please.
And this one does, this one doesn't. This one. Give it the top of this one. Yeah.
Yes, I actually do. Hold on. Get those limits, please. Let me see. All right. We ready? Or you need another minute? Ready? Okay, ready? My limit as x approaches negative infinity of f of x for this first one right here. My limit as we approach negative infinity is what? Should be a positive infinity because as I'm getting bigger here, I'm going up. Okay? Using that end behavior. As x approaches, my limit as x approaches infinity, f of x does what? Goes to infinity as well. So these are both infinity. Down here, my limit as x approaches negative infinity of f of x equals what? That's positive infinity because it's going up. My limit as x approaches positive infinity of f of x is what? Negative 4. What looks like there? What's there? A horizontal asymptote. It's skirting. Can you guys now see when it's shooting all the way down and when it's kind of skirting across? Okay. On this last one, you have both a horizontal and a vertical asymptote. That's proven by limits, and we'll get there in a little bit, not today by any stretch of imagination. But this one, my limit as x approaches negative infinity of f of x is what? 0. And as I approach positive infinity, it's also 0. Okay? What will happen is I'm going to say, hey, if my limits going to infinity are the same value, being 0 or 1 or 2 or 4, there's going to be a horizontal asymptote. Okay? So that's going to kind of get you into where you need to be. All right, that's off of a graph. What?
The back.
The back.
Come on, can I?
Okay, like, I'm sorry, just look at it.
I am.
It looks intimidating, but it's not, I promise.
It's really not.
Okay, you don't even know.
Just
You want to come teach it?
No, I just agreeing with you.
Okay, good. This is where your graphing calculators you're going to want them eventually. Okay? Now, the big thing here is you're talking about a value approaching something else. You're talking about something approaching something else. What you're trying to do is you're trying to condense that piece. So if I took a piece of a graph that was super, super ugly and I zoomed in really, really close on it, would it look like a straight line? If I took this gross graph like this and I took a super, super small chunk, would it look like a straight line? Yeah, because you're taking a really, really small piece of it. That's what the limit's doing. It's just cutting it down into these small, small chunks to find an actual value. So what's going to happen now is you're going to use your table and you're going to use your calculator a lot for this. Okay, your calculator, you guys are really lucky. When I first started doing limits when I was in high school, we had to plug and chug. We didn't have a table for anything. Okay, what we're going to do is we're going to find the limit of this gross function as we approach what number? My limit as x approaches what? 2. Okay, so that number will always go in the middle of your table. And your table should look, I will not use this when we do it in the graphing calculator. You'll see what I use. But this is kind of what the table should look like. 3 on the left, 3. So 3 smaller, 3 bigger, your actual value in the middle. So what we will do is we will take this gross function and we will put in our number. So, hold on one second. Let me put that up there. I had to go about the other way to get a graphing calculator. Okay, here's my graphing calculator because I'm using my own computer. Now, what we're going to do is we're going to plug in our numbers. So what we're using here is we're using 1.997 for x, yes? So wherever there's an x in my original function, I'm going to put 1.997. So here's what it will look like. I will do parentheses, 1.997 minus 8, right? Minus 8 divided by parentheses 1.997 squared plus 4. I'm just inserting that value in, and I'm going to find out what it equals. And we're going to round to the nearest thousandth. So how many decimal points is thousandths? 3. So this should be rounded to negative 0.752. Okay? Now, we're going to do the same thing instead of what are we going to put in now? Now, you know you can do second entry. If you do second enter, it puts your value right back in. And you can use your arrow keys and change that to a 8 and change this to an 8. So what's this one? Darn near the same thing. And 751. What are we going to do now? Change that to a 0.999. So second entry. So it's the same thing, right? When you round it. Do the same thing for 2.001, 2.002, and 2.003, please. So just plug it in. Second entry, just type over it. Type right over those numbers.
How's it smell? You got no lignocins?
It's the ice machine. The wall's falling down.
How is the ice? Is it good?
Mm-hmm. That's very good.
Jared said it was a little overrated.
No, he didn't. Then you wouldn't be coming back in here. Mm-hmm. Yeah.
He
Mm-hmm.
said
Okay.
it's satisfying. But
What values are we really, really close to? So you got negative 0.75, negative 0.749, negative 0.749, right? So what do you think the limit is as x approaches 2? So you got this, you got this, you got this, right? Close enough to that? What does it look like it's approaching from the left, and what does it look like it's approaching from the right? What's it really, really close to?
negative 0.75.
Negative 0.75, which is the same as negative 3/4. Okay? You're trying to get the value for which it's coming on both sides. Now, how annoying is to type that in a bazillion times? It's super annoying, which I don't like. This is why we use our graphing calculators. This is where I would suggest you watch me do it and then do it with me the second time. So, first thing you're going to do is you're going to make sure you have nothing in your y equals. Okay, so go to your y equals and clear it out, please. Then what you need to go is you need to go second table set. So second window. Second window. Should look like mine. Okay? You should see those 4 things on your screen. Yes? It should say table start, delta table, independent and dependent. Your table start should always be what your limit is approaching. So what are we approaching here? 4. You can start there. Actually, I'm not even going to. I'm just going to leave it at 0. It doesn't matter. It's fine. I'm going to leave it at 0. The next thing, I want you to change the delta table to 0.001. Again, if you forget this, it's okay. Go down again. Go to the right to ask. You're going to ask for your independent. Your dependent is going to remain at auto. So what's going to happen here is you're going to put something in for your x, which is your independent variable, and your calculator is going to generate something for your y value. Okay? Now, that's your table setup. If you clear your RAM, you'll have to do this every single time. So can I give you a suggestion? Don't clear your RAM. Just close your calculator. If any of your, if like physics comes around and clears your computer so you didn't put anything in there, you have to redo this every single time. Which I don't know if they do, but whatever. Here's what you'll do. When you're looking here, what are we approaching? What value are we approaching on our paper? We're approaching 4. What's my function? 3x minus 2. So what you'll do is in your y equals, you'll put your function in 3x minus 2. 3x minus 2 will go in there. Now, what you'll do from here, you'll hit second graph. I don't care about the graph. Second graph. Yours might have a number in there. It might not. Mine did not. I started at 0. What I would suggest you write down now is what I'm going to put in. Okay? So I'm going to put them in. It's ready for you. But if it's only satisfactory, then you can exit stage right. Since you're talking poorly. All right. You want 3 numbers smaller than 4. So, but you don't want to use like 1, 2, and 3.
What?
Because remember, we're taking this and we're condensing it, right? We're making it really small. So your 3 numbers that you're going to use are 3.9, 3.99, and 3.999. So go and put those 3 in. That's fine.
so that's cool.
You're welcome.
Just
Okay.
that sign.
Now, are those numbers smaller or bigger? Those are smaller. Okay, so I did my 3 smaller. You're never going to put your actual value in because sometimes it won't work, so don't do that. Don't put 4 in. Now I need 3 numbers bigger. Here's what you will do. 4.001, 4.01, and 4.1. So 4.001, 4.01, and 4.1. What you're looking for is you're looking for what it's approaching coming this direction and what it's approaching coming this direction. What are we approaching? We're approaching 10, right? We're getting really close. 97, 997, 9997, 10003, 1003, 10.3. It's just the ice machine is just falling. Okay? So my limit as x approaches 4 of 3x minus 2 is 10. Okay? Now this time I don't want you to change anything in your table. But the only thing you're going to change is you're going to change your equation. So come in, go to y equals, clear it out, put in the next one. So 2x squared plus x minus 4. You want to look at your, see my table's already messed up because I changed my equation. Let me show you on this one. Okay. All right. Now, what am I approaching here? -1. So you're going to use -1.1 because you want smaller. Negative. Guys, this is the part you got to listen to me. You got to know when it's positive what to use and when it's negative what to use. -1.1. -1.01. -1.001. Oops. Okay, so there's that. Now you need a little bit bigger. -0.999. -0.99. -0.9.
Can you go over? I can't. Sorry, see that. Can you go over the second one?
-0.999. -0.999. -0.99. -0.9.
It's 4 9
No.
to start.
3 9s to start, then 2, then 1.
Yeah, I guess it's just
Then your equation is not right.
Which is what it is.
Check your equation. Because if you try to type over it, yeah, if you try to type over it now. Now, here's the deal, kiddos. If I were you, I would have written down what I wrote down for the positive and the negative. So for that first one, we did 0.1, 0.01, 0.001, right? 0.9, 0.99, 0.999. You're doing that for both. You just got to know if it's positive or negative. You'll always do 0.001, 0.01, 0.1. 0.999, 0.99, 0.9. You just got to use the numbers around it to make it smaller and bigger. Now, here's the part where you need to make sure you're paying attention. I don't know if I can't zoom in on this. As I'm approaching from the smaller values, what am I getting closer to? This is where you got to look at your table. You can't look at mine. What value am I getting really close to? -3. When I come up from the bottom, what number am I getting really, really close to? -3 as well. So my limit as x approaches -1 of 2x squared plus x minus 4 is -3. Okay, let's do one more. What's the first thing we need to do? Type in your equation. Go to y equals and clear it out. So -x cubed minus 4x squared plus 7x plus 9. So the first thing you should always do is put your equation in. I'm sorry, I can't make it bigger. I apologize. Do we have the y equals? Are we good there? Can you guys give me a heads up? Yes, no? We have the y equals? Okay, second table. What value are we approaching right now? -5. So you'll do -5.1. Then what's next? -5.01. Then -5.001. Okay, that's the small ones. Now I got to get bigger. So -4.999. negative 4.99, negative 4.9. What am I approaching? Mm-mm. Mm-mm.
What did I miss?
I heard it. Negative 1. So I'm going 1.9 to negative 0.7 to negative 9.7. Then I'm coming negative 4, negative 1.3, negative 1. This one's harder because it's jumping around a lot more. But you kind of want to look right in between those middle ones. What number looks like it would sit in there? Negative 1. Okay? I would like you guys to try the next one, please. I will help you put it in, though. So go to your y equals. Now, why is this one different? It's division, right? You need to put your numerator before you start typing, because if you type it in wrong, your limits will be wrong. Your numerator needs to go in parentheses, and your denominator also needs to go in parentheses. So you'll do parentheses, what is it, x cubed plus 27 divided by x squared minus 9. Okay, so make sure your y equals looks like mine. And then I want you to try to find your limit as x approaches negative 3, please. What? Need me?
Nothing wasn't working.
Do you need me?
Yeah.
Okay.
So this one, it just keeps getting weird. Super high.
Based on what your limit is.
It's like the same number, but it's not in decimal. There you go. The other ones were perfect sizes.
Based on what your limit is. So
Oh,
ours written down.
because you have a net. This is minus 4
Then you
squared,
know
not negative.
3.01.
Does that make sense?
Yeah, my bad.
No, you're okay. No, I want to get those questions out now so we
Yeah.
understand.
My bad, I just put it.
No, you're fine.